All right, today we're looking at graphing quadratic functions in the vertex form, which is y equals a times x minus h squared plus k. Your hk is going to be your vertex. Finding the x value of the vertex by solving the parentheses for 0, and the y value of the vertex is just the k value in the equation. So if you look up here in this set of parentheses here, if we solve the set of parentheses right here for 0, figure out what makes that 0 inside, then we'll find the x value of the vertex. And the y value of the vertex, likewise, is out here, and it just is what it is. If it's positive, then it's a positive y value, and if it's negative, then it's a negative y value. The a value in front of the parentheses tells us if there's a stretch or compression to our parabola. Stretch will make it taller and skinnier, and the compression will make it wider and shorter. To find the y-intercept, we plug 0 in for x and solve. To find the x-intercept, we set the equation equal to 0 and solve for x. Remember that there could be more than one 0. Your domain will always be all real numbers, and then your range, if it opens up, it'll be your min y value to infinity, and if it opens down, it'll be your negative infinity to your max y value, which can be found at the vertex. All right, so let's look at an example here. Let's start off by determining what the vertex is. So as I said, you need to find what makes a 0 in your parentheses. So if I look here, 3 minus 3 equals 0. So our vertex, the x of our vertex is going to be 3, and then your y value of your vertex is just the k, so negative 4. Your y-intercept. Your y-intercepts can be found by plugging a 0 in for x. So the y-intercept, you're going to plug a 0 in for x, so y equals 0 minus 3 squared minus 4. And so negative 3 squared is 9, so we get y equals 9 minus 4, so y equals 5. And so that tells us that at 0, 5, we have a y-intercept. You will always have a vertex and you will always have a y-intercept. X-intercepts you may or may not have. So let's look and see if there's x-intercepts. I imagine that there will be, because the vertex is at 3, negative 4, and the graph is opening up because the a value is positive. And so a value, we look here in front, there's nothing there, so we assume it's a positive 1. So it's opening up. So I assume it is going to hit the x-axis. So our x-intercepts. Our x-intercepts, we plug a 0 in for y. So 0 equals x minus 3 squared minus 4. We want to solve for x. We want to use the opposite of order of operations. So we're going to look for addition, subtraction, multiplication, division to get rid of. Addition, subtraction first. So we're going to get rid of the minus 4 by adding 4 to both sides. And that gives us 4 equals x minus 3 squared. To get rid of the squared, we will square root both sides. The one thing to note is whenever you take the square root of both sides, you need to add the plus or minus. And since we know the square root of 4 is 2, we can say plus or minus 2 equals x minus 3. Add 3 to both sides, and we get x equals 3 plus or minus 2. And so what that means is that we have x equals 3 plus 2 and x equals 3 minus 2. And so that gives us x equals 5 and x equals 1, meaning that our x-intercepts are 5, 0, and 1, 0. We can plot those also on our graph. So at 1, 0 and at 5, 0, we have our x-intercepts. Also to note, we have our line of symmetry, which comes down the middle of the graph through the vertex. So our line of symmetry is x equals 3. And then we'll plot our y-intercept of 0, 5. And using the line of symmetry, we know if we have a point 3 to the left, we also have a point 3 to the right. And so there's a nice 5-point graph. Okay, as I told you before, the domain is always all real numbers, You can use this R to indicate all real numbers. And the range is going to go from the lowest y value to infinity because it's opening up. So our lowest y value is when x is negative, or when y is -4. So we're going to say bracket -4 to positive infinity, or we can say y is greater than or equal to -4. All right, let's take a look at our next example. All right, so the first thing we want to do is identify the vertex. And so again, we want to look inside of our parentheses and determine what makes a 0. And so we see that -1 + 1 is 0. And so our vertex is going to be -1, 2. All right, our y-intercept. Your y-intercept again is going to be when x equals 0. So we'll plug a 0 in for x. So y equals 2 times 0 plus 1 squared plus 2. 0 plus 1 is 1, and squared is 1. Times your 2 gives us 2 plus 2. So y equals 4, giving us a y-intercept of 0, 4. Let's go ahead and look and see where our vertex is on the graph. Vertex is at -1, 2. And our y-intercept is 0, 4. We can go ahead and use our line of symmetry that goes through the x. Using the line of symmetry, we get our third point because we have a point 1 to the right, so we have a point 1 to the left. Now, you can already see that we don't have x-intercepts here. The graph is opening up. The vertex is above the x-axis. But I do want to show you what this is going to look like if you're trying to solve for your x-intercept. So if we're looking for our x-intercepts here, you plug a 0 in for y, and we get x plus 1 squared plus 2. The first thing we're going to do is the opposite of order of operations. So we're looking for addition, subtraction to get rid of. So we get rid of the plus 2 with subtraction. And so we get -2 equals 2 times x plus 1 squared. We are then going to divide by the 2 in front of our parentheses. In doing so, we get -1 equals x plus 1 squared. And to get rid of the squared, we need to square root both sides. And as you see, we get a negative under the square root, which means no solution or no x-intercepts. All right, so where can we find a fifth point? Well, just like with the previous video on graphing quadratics, we can find extra points. We can find extra points by plugging in a point to the left or right of the vertex. We already have a point to the right of the vertex, so let's go 2 to the right of the vertex, which is when x is 1, or you could use when x is -3. I think when x is 1 is probably a little easier. So if we go back to the original equation and plug 1 in for x, we get y equals 2 times 1 plus 1 squared plus 2, which gives us 1 plus 1 is 2, squared is 4, times 2 is 8, and 8 plus 2 is 10. So we have a point at 110. So if we go up here on our graph to 110, so here's 4, 6, 8, 10. So at 110 we have a point, and that's 2 to the right of the line of symmetry, so we'll go 2 to the left of the line of symmetry, and we get our fifth point for our parabola. Domain and range. Like I said before, domain is always all real numbers. Again, this graph is opening up, so we're going to find the min value, or the min y value, which is down here at 2. And so our range goes from 2 to infinity, or you can say y is greater than or equal to 2. All right, one last example. If you notice here, we have a negative in front of the parentheses, meaning this graph is going to open down. There is no stretch of compression. And let me note one more thing about the previous example. Given that there was a 2 in front of the parentheses, we had a stretch. And that's why the graph was a little taller and skinnier than a regular parabola, which we saw in the first example. All right, so example 3, vertex. You always want to identify your vertex first. And so what makes a 0 in the parentheses? A -2. So -2, 3 is our vertex. Our y-intercept. Y-intercept is whenever we plug a 0 in for x. So we get y equals negative times 0 plus 2 squared plus 3. And so y equals negative 0 plus 2 is 2 squared is 4. But because of the negative out in front of the parentheses, we're going to get a -4 plus 3. So y equals -1. And so our y-intercept is 0, -1. If we go over here and look at our graph, we can see that the vertex is at -2, 3. Our y-intercept is at 0, -1. Let me make that red. Again, our line of symmetry comes down through our vertex. And so 0.2 to the right, we have a 0.2 to the left of the vertex. Now, x-intercepts, it's obviously going to have x-intercepts. I do want you to find those. So for our x-intercepts, plug 0 in for y again. So 0 equals negative times x plus 2 squared plus 3. Again, opposite of order of operations. Subtract the 3 first. And so -3 equals negative times x plus 2 squared. If we had to take the square root from here, we would get a no solution, but there's a negative in front of the parentheses, which is like a -1. So if we divide by -1 on both sides, we get a 3 on the left equals x plus 2 squared. So square root both sides. We don't know the square root of 3, so we can't simplify that. But we have to put the plus or minus in front of it. So plus or minus the square root of 3 equals x plus 2. We subtract 2 from both sides, and we get x equals -2 plus or minus the square root of 3. And so if we get an approximation for this, x is approximately, we have -2 plus the square root of 3. Which gives us a -0.267. And if we take -2 minus the square root of 3, sorry about that, we get a -3.73. And so we're going to have to approximate those values. -2.3 or 2.67 is probably about right here, and -3.73 about right here. And so that gives us our 5 points to draw our parabola. If you wanted to find 2 other points other than the x-intercepts, you could. Well, not other than the x-intercepts, you need those. It's important that you know how to solve for the x-intercepts. But you could find 2 other points if they fit on your graph, just like we found the extra points in the previous example. Our domain, again, it's going to be all real numbers, and our range this time is going to go from the maximum y value because it's opening down. Our maximum y value here is 3, and so we're going to go from -infinity to 3 with a bracket. Remember, range and domain always go from least to greatest, so we want that -infinity on the left, or we can say y is less than or equal to 3. All right, I hope this video helps, guys.